Then here is influence line diagram for RA. Lift point A by unity, hence the ILD. Influence line diagram for RB. Lift the beam at the support B. Rest same. Influence line diagram for shear at G. When shear is released at G and unit displacement is given, then ordinate will be 1/3 and 2/3 for the load to the left of G. RD is equal to 0 and RC is upward. Implies as per the sign convention shear at G in BG is positive. As per sign convention shear at G in BG is negative. Influence line diagram is the graphical representation of the support reaction shear force of the bending moment at a section when the unit load moves from one part of span to another. Influence line diagram is the graphical representation of support reaction shear force or bending moment at a section when unit load moves from one part of span to other. This is one. This is one. This can be the hinged. This can be the pinned. This can be the. Then the shear force diagram can be drawn like that. Okay. And the bending moment diagram can be drawn like that. Bending moment diagram can be drawn like that as from the concepts of SOM. Influence line diagram for support reaction as per Mueller-Bersele principle to draw the ILD for support reaction at the simple support. Remove this support without removing any other support and give unit displacement. Deflected shape is itself the ILD for support reaction at simple support. This can be the hint. This is simple support. This is fish support. By same principle to draw ILD for support reaction and fish support, removes support without releasing moment and without removing any other support and give unit displacement. Deflected shape is itself ILD for support reaction and fish support. This is ILD for V is equal to question mark. This is A, this is 10 meter, this is 1, 4 meter to B. This is 10 meter, this is 4 meter, this is 0.4, this is 1, this is ILD for VA. Then ILD for VB. This is A, this is LY2, this is LY2, E, B, 2L, C, this is LY4, this is LY4, F, D. DS is equal to gamma minus S is equal to 4 minus 2 plus 2 is equal to 0, which implies determinate structure. 1, for example, here is a reaction for A, ILD for VA. For example, here is 1, there is a pin support, then here is a horizontal. Then inclined for ILD for VB. VB for example, here is 1, it is 1.25. Then it changes direction. Then here it is theta. Theta, this is 2L. This is Ly4. This is negative. This is 1 by 8. This is ILD for VB. This is negative. This is theta. Then here it is 2L. Here it is 1. Here it is 9L by 8. Here it is 1.125. This is ILD for VB note. This is then ILD for VD. This can be 1. This can be done like that. Determine minimum reaction, maximum negative reaction at B when UDL of 5 kN per meter is moving on this span. This is A, this is B. This is 1, this is 1. This is A, this is Ly2, this is Ly2. This can be the rolling spot. Ly2, Ly2. Rolling spot. Ly2, Ly2 rolling spot. E, B, C, F, D. Minimum reaction at the rate of B is equal to half into 1 into 2 into 5 is equal to 5L. Then it is 1, this is 1. It is theta, this is theta. It is negative 1. Theta, theta, 1. ILD for VA. It is 1, it is 2. Then it is negative 2. Then it is ILD for VB. Then it is the two wheel loads 10 kN and 55 kN spaced 5 meter apart along the UDL of 3 kN per meter and a span of 2 meter is moving on SSB of length 10 meter. Determine the maximum spot. Here it is A, it is 2 meter. Here comes a UDL 10 kN, 5 kN. Here it is 10 meter. It is B. It is 0.5, it is 0.8, this is 1, this is 5 meter, this is 8 meter, this is 10 meter. Mass reaction is equal to 10 into 1 plus 5 into 0.5 plus half into 1 by half into 1 into 0.8 into 2, which is area under curve, into 3 is equal to 10 plus 2.5 plus 5.4 is equal to 17.9 kN. ILD for shear force at a section as per Mueller-Breslau principle. To draw the ILD for shear force at section C, cut C without removing any other support and give equal iteration at both adjacent supports such that total ordinate at C is equal to 1. Deflected shape is itself ILD for shear force at D. Deflected shape is itself ILD for shear force at C. This is A, this is C, this is B. This is A, this is B. This is A theta, B by L, A by L, B theta L. Tan theta is equal to B by L divided by B is equal to realize tan theta is equal to 1 by L. A, C, B, positive. ILD for shear force at the rate of C. This is A, this is E, this is B, this is G, this is C, this is F, and this is D. L by 2, L by 2, X, L minus X, L by 2. This is pinned, L by 2. This is pinned, this is pinned, this is roller. This is roller, this is pinned. This can be the hinged. Here it is 1 by 2. Positive theta, negative x by L, L minus x by L. Here it is positive theta, negative 1 by 2 ILD for shear force at the rate of G. Here it is 1. Right hand side of B. 1 positive, negative. Is the inclined line downward and inclined line upward. Here is a vertical line. Here is inclined line upward, inclined line downward, then positive. ILD shear force at the rate of left hand side of B. Here it is the 1. Here is the horizontal line, then here is the inclined line downward. If distributed load is 10 kN per meter and left and LL is 20 kN per meter, then determine maximum shear force at the rate of left hand side and right hand side of B. L is equal to 10 meter. Maximum reaction on right hand side of B is equal to half into 0.5 into L plus half into 1 into L is equal into 20 plus 10 minus half into 0.5 into L into 10 is equal to 7.5 into 30 minus 25 is equal to 200 kN. Maximum reaction at the rate of left hand side of B is equal to half into 1 into L by 2 plus 1 into L by 2 into 20 plus 10 is equal to 7.5 into theta is equal to 225 kN. ILD for bending moment at section C. As for Mueller-Breslau principle, to draw the ILD for bending moment